Solving equations with fractions. Typically, we don't mind solving equations too much. We have our basic one-step, two-step equations. We have a multi-step equations we've worked with where we have variables on both sides, parentheses, such. But then the fractions come in and they kind of throw us a little bit. So an equation with fractions looks something like this. Let's say we have 2/3 x minus 5 equals, and let's go 1/2 x minus 7/12. Just kind of make something up there. And definitely, it looks pretty bad when you're sitting there having fractions sitting in there. And we're going to have to get those things combined. And we've learned about common denominators before, things about like that, working with fractions. They still might not be our favorite thing, but we're going to use that common denominator. So what I want to do is we're going to multiply each term by the least common denominator, 12 in this case. Each term by a 12. So the idea on equations was, from your past, would be if you do something to one side, you have to do it to both sides. So that's all I'm going to work with here. I'm going to multiply everything by 12, which means I'm multiplying both sides by 12. So I'm just going to kind of rewrite the equation here. So I'm down here in a different part. Now the reason I picked 12, because I'm looking across, I have really 4 denominators, but this one's a 1, so it's not going to change anything. So I have a 3, a 2, and a 12. So the common denominator between those 3 numbers would be a 12. So what I want to do is multiply each term by that 12. Doesn't matter what side I put the 12 on. And what this is going to do is eliminate my fractions. So 3 goes into 12 4 times. Then I'd have 4 times 2 is 8x minus, nothing cancels because this was a 1. 12 times 5 is 60. 2 goes into 12 6 times. So then I'd have 6 times 1x is 6x. And then over here the 12s cancel, leaving me then just a minus 7. Now, the benefit of canceling out the fractions, using that common denominator to eliminate the fractions, is simply because what that allows me to do is get an equation like this that I have seen and solved before. Right? So it's not solved, and I'm not going to say this is always the easiest equation to solve, but I do know this much. That's a lot better than this. Okay, so now I'm back into something I've done before. I've got variables on 2 different sides, so I want to get those together. So I'm going to subtract that 6x. That gives me 2x minus 60 is negative 7. Now I'm back to that 2-step equation. Add my 60 over. 2x is, let's see, that'd be 53. And so then x would be 53 halves. So what we're going to do is focus on this piece right here. We're going to multiply by that least common denominator. That's going to eliminate my fraction. Once the fraction is gone, then it's back to an equation that I've seen before, something that's not new. That's my focus here. Okay. I don't care where the fractions are or what they are. I'm trying to get rid of them. So let's say here on number 2, let's go with 3/5 x minus 2/3 equals 7/15 x plus 1/3. Now I do see I have a couple of fractions here that are both thirds, but I'm still thinking of, I want to use that common denominator so it eliminates all of them. Okay? So I'm looking at a 5, a 3, and a 15, and I'm thinking, all right, what is my least common denominator? Okay. And in this case, that least common denominator would be 15. 5, 3, and 15 all go into 15. Okay. That would be that common denominator. So what I'm going to do is now multiply each term by 15. Right? Now some of you are fine working in your head. I think that's also nice to kind of write the 15 up there because you can see the canceling happen. 5 goes into 15 3 times. 9x minus 3 goes into 15 5 times. 5 times 2 is 10 equals, here the 15's cancel, 7x. And over here 3 goes into 15 5 times, so 5 times 1 is 5. And there we're getting back to a little bit more familiar equation there. So the goal again, multiply by that common denominator. It's going to get rid of all of our fractions that are in our way. Now I'm just combining like terms. 2x minus 10 is 5. Add my 10 over. 2x is 15. X is 15 halves. X is 15 halves for that piece. So we're going to use that common denominator, eliminate those fractions. It's going to get a few extra ones in here. Let's go with 2/3 x minus 1 plus 5 6x equals let's go 2/18 x minus 5/9. We got that 1 sitting in there, doesn't matter, there's a denominator of 1 under the 1. So I'm scanning across and I see denominators of 3, 6, 18, and 9. Technically, I see 3, 1, 6, 18, 9. So I'm just thinking, wait, what's that common denominator going to be? 3, 6, 18, and 9 all go into 18. So I'm going to multiply each term by 18. Going to write it by each one, and my goal is to then eliminate those fractions. 3 goes into 18 6 times. 6 times 2, 12x. Nothing canceling here, so 18 times 1 is 18 minus 18. 6 goes into 18 3 times. 3 times 5x is 15x. We're here on the right side. 18's cancel, so 2x, and then 9 and 18 twice, 2 times 5 is minus 10. Again, it's not solved, but it is definitely a lot easier than it was before. So here I have actually like terms I can combine on the left. 12 and 15 is 27x, minus 18. Here we've got 2x, minus 10. Move my 2 over, 25x. Minus 18 is negative 10. Move my 18 over. 25x is 8. Again, moving stuff left and right. We've done that many times. And so then x would be 8 over 25 for that final solution there. See, and if we can eliminate the fractions, we can get an equation back to looking like what we've done before. And we're going to eliminate them by using that common denominator to multiply each term by to eliminate those fractions.